Trevor's grade's going down over there.
Actually, I'm not the one saying this is Ballard. That's totally Jacob. I'll throw him under the bus. My grade is low enough as it is. What?
I didn't hear Jacob's voice at all. It sounded awful lot like Trevor. Okay.
What are you making stuff up for? Don't you dare.
All right, you tell me, what do you want me to do here, guys?
Part 2, multiple choice, homework number 45.
Okay. Which one?
We can't go in order.
Doesn't matter which one, because you might not have time for everything, so you tell me what you want.
Questions, people.
Can we come back in?
After class? I was here last night. Number 1, that one? Okay. It's on haiku. There's one that says multiple choice. It's a practice test versus a... Okay. All right. Mine's going to look different than yours, right? Because yours, I converted it to an online test. All right. So velocity vector. So they get the velocity vector. They want the magnitude of the acceleration vector to the nearest tenth at time t equals 3. So first I got to get the acceleration vector. What would my acceleration vector be?
It would be
6t and negative 9. Okay, and then specifically they want the magnitude to the nearest tenth at time t equals 3. So magnitude is basically your derivatives squared, but we got to plug our t in there, right? 18 squared and negative 9 squared, because we plug the 3 into there, right? And that gives us the 18. The 9 is 9. Under there, when I did that, I got 405. And then my final answer was 20.1. Obviously, we'd have to have a calculator on this one. Okay?
Yeah, and then after that,
All right. Number 2 on that? Okay. All right. Number 2 is weird. Okay? We needed to know that we had to do the derivative over the magnitude of the derivative to solve that one. Okay? Which I know was in there in our notes somewhere. All right? So, what is the derivative vector basically to start with? 3t squared and then what? 4t. Okay, so that's your numerator technically. We're going to split it up here in a second, right? And then the denominator is the magnitude evaluated at 2. We're going to eventually evaluate the numerator at 2 here too. I don't know why they showed it to me separate, but they did. All right, so when I plug in, I need the derivative squared plus the derivative squared, right? So when I plug a 2 into this, what do we get? 12. Okay, and when I plug a 2 into this, what do we get? 8. Okay, so what is my denominator actually become? Square root of 208? Is that right? Are we sure? All right, because I ended up reducing it to 4 over is 13 times 16, 208. Check it out. Yeah. Because I got 4 squared to 13. Is that right? So you'd break it into 16 and 13. Because it reduces, because we have to reduce to get that answer, right? So you'd have to actually do the reduction on it. Normally we would just leave it, right? All right, now I'm going to plug my 2 into these guys here. So when I plug the 2 into the 3t squared, what do we get? 12. Oh, it's already there, isn't it? 12 and 8. All right, now let's reduce those. So let's see, 4 into 12, how many times? 3 over square root of 13. 4 into 8, how many times? 2. So the big thing on this one was remembering that for this particular one, you had to do the derivative over the magnitude. Okay. All right, what would you like me to do next? Number 3. All right, the velocity of the particle is that. They want the magnitude of the acceleration, so it's basically the same thing we just did. All right, what would the acceleration vector be? 8t and 3. Okay, and then I'm going to do the magnitude, and I'm going to plug in 2 at the same time. We know it's the derivative squared. So when I plug a 2 into this, what do we get? 16, and when we plug a 2 into that, we still get 3. And when we add that up, we get... I have 265. It helps if you get that number right, because I didn't get that number right at first. So that's how I got it wrong to begin with. And it turned out to be 16.3. Number 6? Sure. It's all digital. You guys, the practice test is just a practice test. I would expect you to have it written out in your homework for your stamp, okay? It at least shows you what answer is right. I mean, that's the best you can get out of that. All right, I'm doing number 6. We probably want to put this, I did it by hand, but you probably want to at least look at the picture in your calculator. You don't know if I'm going to put it on a calculator or non-calculator, so let's do this one by hand, and we can do some of the others by calculator if we need to, okay? I think some of the ones that are on the other one I did more by calculator than these. All right, so let's get that graphed right now. Thank you. You don't have to go now. All right, so are we typing it in? Let's practice typing that in so you at least can see the picture, okay? Documents, Scratchpad. Okay, you got to remember to change it to polar, right? So menu, graph, edit, entry. We're going to go to polar. And we have to type in cosine 2 theta. You want to make sure that you're in radian mode, right? 2, and the theta hides here. Enter. Oh, nice little rose curve. And then there was a second one that we want to type in polar that was 1/2. So I'm just going to put in 0.5. Hopefully this weekend, since parent night's Monday. Yeah.
You put in 0.5 theta?
I put in 0.5. It was just 1/2. It was a circle. So all we're really looking at and examining, because it just says between they were nice. They gave us the endpoints, negative pi over 4 and pi over 4. I almost didn't need it, but it's always good to have the picture, okay? In theory, for the AP test, you're supposed to know what the pictures look like. That's why we did all that graphing stuff, right? We've kind of been lazy and relied on the calculator for us since we've been integrating it. All right. So they were nice and told us that we are integrating from negative pi over 4 to pi over 4, which if I looked at that on the graph, that looks about right? It looks like it's about in the middle, okay? So we're going from negative pi over 4 to pi over 4. So let's see, we're going to find the region that lies between those two curves. So remember that our formula is 1/2 the integral of the function, and what do I have to do to the function? Square it. Okay, so you have to have that memorized for the actual test. Okay, I'm going to choose to put the 1/2 out in front of everything. So I'm only going to deal with that once. And really what I am doing, let me make sure I have this right down. Okay, so what I am doing is, did I go from, how did I do pi over 6? Oh, find the area, the region that lies inside the polar curve. Yeah, I bet that isn't pi over 4, is it? Because I don't have it written down. I have it written down as pi over 6. We better calculate it.
Wait, isn't that the one you did last night?
It's sort of similar. Let's go back and look at that on the calculator. Trace over the top of it. Because pi over 4 would be more in between, wouldn't it?
Sure.
Yeah, so you probably want to do a menu. And we'll put the unit circle decimal points up for the test tomorrow. We want to do a trace and a graph trace and kind of see if we can get it over the top, hover over the top of that spot, which is not going well, is it? 0.5 something, I don't know where my decimal, I think they're hidden some back there somewhere. So if we put that in as a decimal, it would be probably more pi over 6 than it would be pi over 4. And if we imagine that line in there, that would be our pi over 4 line, wouldn't it? And it's not splitting it exactly in the middle, so it's got to be pi over 6. Okay, but again, I'll make sure the decimal points, if they're not up, remind me tomorrow. Okay. All right, so let's go pi. So it's not really pi over 4. Oh, I can't delete it now. We're just going to change it to pi over 6. Okay. Let me go to a different color. All right, so these are going to be over 6 and over 6. All right, so I'm integrating from negative pi over 6 to pi over 6. All right, we've got to find the region that lies inside the polar curve and outside the circle. So this is, we want it to be inside this blue part, okay? And inside the blue part and outside the circle would be over here, wouldn't it? Okay, so really what I'm doing, think about this in terms of like how we would have done a top minus a bottom, or if I do the polar curve here, don't I need to subtract that chunk?
Washer.
Yeah, it's kind of like a washer, huh? So think about that kind of setup when I write this down. So I'm going to do that squared minus the 1/2 squared. So it's set up almost like a washer, okay? It's not a washer because we're not revolving anything, because I checked a couple times and the revolving stuff isn't on your AP test, okay? So I'm not teaching it this year, okay? I also didn't teach area of the surface. So if you run across that, that wasn't in the course description either. So I didn't bother with it. Okay? I apologize if they come up, but I think you know enough to pass, right? Okay, we have to do some replacement here. Okay? So I would replace this, and I may be kind enough to maybe put some trig identities on the test for you, but don't count on it. Okay? We'd have to replace with a trig identity. I believe it's the 1 minus cosine 2u, right, over 2. Is that right? Huh?
I think it's plus cosine.
Is it plus? Yes, it's plus on that one for cosine. All right, so now here's the thing. I have to do 2u. That whole thing is the u. So what's that going to become? 4. Okay, now I'm going to write it out as two different fractions. So I'm going to say 1/2 plus 1/2 cosine, maybe, of 4 theta. So all I did was break that guy up and I plugged the 2 theta in there. All right, and then minus, what's 1/2 squared? 1/4. All right, before I go to integrate, and I am going to try to do it by hand because look at the answers. They're all by hand answers, right? All right. Not that I couldn't do that on the calculator. I probably could, but... what's 1/2 minus 1/4? 1/4. Okay, now let's talk about the u sub I would need for this. I would have to have a 4d theta, right? Which means I would have to have... what added in here? 1/4. I'm not even going to keep writing all of it out. So if I have to have a 1/4 in front, what's that 1/2 going to become? 1/8 cosine 4 theta d theta. So now I did the u sub, I just didn't use u, right? So now let's go ahead and integrate. So I'm going to keep that 1/2. Let me erase this junk over here. Get rid of that.
For the 1/4 out front,
Mm-hmm.
you added 1/2 plus 1/2.
Yes. This one. No, I did the 1/2 minus the 1/4.
Minus 1/4.
Yeah. Okay. Let's keep going. So we've got 1/2 out front. I'm integrating now, so I get 1/4 what? Theta. When we integrate cosine, what do we get? Sine, and it's a positive, so sine 4 theta. And we have to sub in from negative pi over 6 to pi over 6. All right. So we have 1/2. What is 1/4 times pi over 6? Pi over 24, good. Plus 1/8. What's cosine? Or no, it would be sine of 2/3, right? sine 2/3 pi, 2 pi over 3 for the pi over 6 into there, minus, would have negative pi over 24 plus 1/8 sine of negative 2 pi over 3. Keeping the 1/2 out front for now. I've got a pi over 24. Sine of 2 pi over 3 is right here on the unit circle. Out 0, up 1. It's got to be square root of 3 over 2. Is that right? So square root of 3 over 2 plus, times 1/8 is square root of 3 over 16. Look at our answer choices. We're getting close to something. Okay. Not sure we're close to anything yet, but we're close to something. All right, that's going to turn, we're going to turn the signs, right? So it's going to be positive pi over 24. And it would be negative 2 pi over 3. Negative 2 pi over 3 would be that coordinate, wouldn't it? So isn't it going to be negative square root of 3? Which it's already minus because of that negative sign. So it would be negative square root of, negative square root of 3 over 16, which is going to go what? Positive. So check this out. You have 1/2. I'm not reducing on purpose. Plus 2 square root of 3 over 16. If I distribute that 1/2 in, what's going to happen to the 2's in the numerators? They're gone. So pi over 24 plus square root of 3 over 16. And again, I don't think the calculus part was that bad. If I did this, would I put in a bunch of these? I'd put in 1, right? Is it E? Oh, the plus, not, okay, thank you. Let me do, you want to go back to something easy? Number 4. See, aren't you glad I grouped the vectors in with the polar integration? So there was something easy on the test? That was smart, wasn't it? Okay, so number 4. All right. So we've got the acceleration vector, particle whose motion is defined by this x value and that y value. It wants, find the acceleration vector. Okay, so acceleration, that's the position. How many times do I have to take a derivative to get to acceleration? Twice. Okay, so what's the first derivative? Plus 2 and 6. Okay, and then what's the next derivative? And don't get something like that wrong. I shouldn't have needed to do that one. Number 9. And then I'll do number 5. Let's look at number 9. Number 9 is actually a really neat problem. Okay? It looks really, really hard, but it's not. Okay? All right. So it says we got to find the length of the polar curve. Okay? So polar curve formula was something like, because the length means arc length, right? When you see length of the curve, it's implying arc length. So you have to take the function the way it looks, right, and do what to it? Square it. And then you're going to add, what do we have to add to it? The derivative, and what are you going to do to the derivative? Also square it. Okay, so that's kind of the generic formula for polar curve. I don't know why I used F's versus R's. Same difference. Okay, so let's go ahead and plug this in. What are you going to use as your limits? 0 to pi. Okay. All right, so my function squared would be sine theta minus cosine theta squared. Plus, I got to take the derivative and square it. So when I take the derivative and square it, what's the derivative of sine? It's cosine, not negative cosine. What's the derivative of cosine? So which is going to make it positive sine in this case. All right, we got to FOIL each one of those. Watch what happens, though. Don't groan. This is an awesome problem, okay? So pretend we had a sine minus a cosine there, right? What's sine times sine? sine squared theta. And then the middle we would get -2 sine theta cosine theta. And then at the end we have positive cosine squared theta. Plus, we've got to do this thing, cosine theta plus sine theta. There's awesome trig in this. Okay. All right. Cosine times cosine is going to be cosine squared. The middle would end up being +2 sine theta cosine theta. And sine times sine is sine squared theta. All right. This and this cancel. What is sine squared plus cosine squared? And what is cosine squared plus sine squared? Isn't this a great problem? All right. I like this one. Tuttle's grade keeps going down today. Okay. Was it Tuttle or was it Jacob? All right. I don't know who that one was. It was Jacob. Okay, so Jacob and Tuttle's grade has gone down today. All right. It's got to be a theta. Okay, and then we plug in, so square root of 2 pi minus 0. How nice was that?
That was great.
That was awesome, wasn't it? Okay. Number 5. Oh, just slide 5. Okay, uh-oh. It just jammed. No, we're not still taking a test. All right. Start. No, you may not take the test June 3rd. Nice try, though. I won't be around to grade it then. Where is it? Where is it? Where is it? You will have already graduated. You won't want to take another test. And now. Come on. It's coming. All right. So number 5. Let's talk about it while it's coming back, okay? Shh. Listen. Shh. So it says we got to find the magnitude of the acceleration. They give us the position. So what do I need to do? Derivative twice. What would the velocity derivative be? 1/2 t to the -1/2. So write that down. 1/2 t to the -1/2. Okay. Did it come back up? All right. And then what would your derivative on the y component be? 3t squared. Good. All right. This one was which one? 5? Okay.
Can you do number 6 on that?
Yes, I can. I'll do that one next, okay? Let me finish this number 5 first. All right, so we said we're at 1/2 t to the -1/2 and 3t squared, right? That's velocity. Acceleration, we get to what? -3/2 and then 6t. And then I need to find magnitude. So another way I could do this is, could I do my calculation within the vector and then put it into the magnitude? Yeah, that's just as easy. I'm going to move this, though, to the bottom, yeah. 3/2 and 6t. Now I'm going to plug in, what number am I plugging in? 4. What's smarter to write than 4? 2 squared. All right, so the 2 squareds cancel. What's 2 cubed? 8 times 4 is 32, and 6 times 4 is... So there's my numbers, and I need to take those numbers and I plug them into the square root and square them, right? So -1/32 squared plus 24 squared.
Square root of 576.
The whole thing is 576? Okay, which should end up being 24, right? Which was A.
So it's velocity versus acceleration, but the magnitude is
The
square root of...
square root, you gotta ask what the magnitude they wanted. They wanted magnitude of acceleration.
Oh, so if
We
that's
could have done
velocity.
magnitude of velocity. Okay? Then we would have been up one more. Okay, 6 on the other one. There's one I gotta do off my phone. Alright. Let's look at 6 on the other one. Keely wanted 6. All right. Let me find my answer to it. I wrote it down. Okay, here we go. You ready? So, I've got a particle moving along this curve. It's got that as the x component of the derivative. At time t equals 0, we've got this point. Find the position of the particle. So we've got to find a position, which means we're going to probably have to integrate somewhere at time t equals 1. All right, so position means integrate. So I'm probably, the only thing I could integrate would be this, right? So let's go ahead and integrate x prime of t. So I'm integrating t plus 1 dt. So when we integrate that, what do we end up with? T squared over 2 plus t, good. All right, plus what? C. So what I need to do here is solve for c. Remember, this is acting like a y value. This is a t. So what do I get to plug in for t? 0. So what's going to happen to both of those? Cancel. Look at, here's a point though. That gives me a y value. What are we plugging in for the y value? Something's wrong. I did it backwards.
Whoa.
What happened? Oh, I plugged in the x. Okay, so this is not acting like a y value. My fault. What component is it? The x component. So I'm going to plug in the x value, which is 1. Okay. So now I have, if I redid my function is x of t equals t squared over 2 plus t plus 1. Okay. C is going to equal, in this case, it equaled the x value, yes. If it had been, if it had given you y of t, you would have put in the y value. Okay? All right, but that is just the x. They wanted me to find the actual position at time equals 1. So could I get the x position at time equals 1? What am I going to do? Plug in a 1 into this thing. So 1 squared over 2 plus 1 plus 1. So 1/2 plus 1 plus 1 is 5/2. Good. Okay, now that's not my final answer because that's only the x value. Do you see anything that we haven't used yet that might give us the y value? Yes, so our y value comes from here. We're going to do the natural log of the x that we got, which is 5/2. So our position is actually, let's see, I don't know if they didn't put it in, I didn't put it in vector form. That would be our position. Okay? All right, what do you want to do next? 7 and 8 on the other worksheet? Okay. On the multiple choice is what they're asking for. All right, we need the area. Okay. So the area of the region located in the first and fourth quadrant bounded by the polar curve. All right, when I graphed it, I'm going to save time on the graphing. Or when I looked at the book problem and they graphed it. So I did get this, I stole it out of a book. It looked like that. Okay? So it's symmetric. So on the symmetric ones, we can we can trick it a little bit and just get half of it. So if I were to look at my limits on that, it starts where? Good, and it ends at pi over 2. Excellent. Okay, so that's where we're going to start with that one. So I'm going from negative pi over 2 to pi over 2. And again, looking at the answers, it would have probably been a non-calculator. I want to double it, don't I?
Right.
Because, oh, wait. It says only in the first and the, so do I need to double it?
No.
In this case, no, okay? But my formula does say I have to do 1/2 times the function squared. So I'm going to take this guy, sine theta, d theta. All right, what does instinct tell you to do next? Foil first, so what, 9 plus, what would my middle be? What's 3 times 2? How many of those do I have? 12. So it's 2 sine theta. And then 2 sine theta times 2 sine theta would be 4 sine squared theta d theta. Notice I kind of left my limits off to save space. I'll put them back on in a few minutes. I need to replace that because we definitely don't want to integrate that thing. So plus 12, so it's one of our funky, so you're pretty much guaranteed somewhere I'm going to put in that funky identity, right? That you, in theory, should know by May 7th, okay? Well, maybe tomorrow, I don't know, we'll see. All right, so I'm putting it in, I'm splitting it into 2 fractions. 1/2 minus 1/2 cosine 2 theta. What are we going to do with that 4? Distributes. I'm doing a lot of algebra in here. More algebra than calculus. So it's going to end up being plus 2 minus 2 cosine 2 theta, right? Can I still keep simplifying? Can't I put the 9 and the 2 together? Yeah, what's that going to be? 11 plus 12 sine theta minus 2 cosine 2 theta d theta. Ooh, don't I have a u sub right here? What would we get out of the u sub? 1/2, so what does that do to this front part here? Cancels, makes it 1. Okay, so now let's integrate it. And I'm going to put my... I know I've got to put these guys back on, right? So we have 1/2. When I integrate 11, what do we get? 11 theta. When we integrate sine, what do we get? Negative cosine theta. When we integrate cosine, what do we get? Sine 2 theta. Shh. From negative pi over 2 to pi over 2. All right, at this point, you're plugging in. Do you want me to keep going or no? Yeah, okay. So 1/2, check out what happens with this. This is pretty awesome. All right, so we've got 11 times pi over 2, which would be 11 pi over 2, right? Minus 12 cosine of pi over 2. What's cosine of pi over 2? 0, that's gone. Okay. Minus, I put a pi over 2 into here. And what does 2 times pi over 2 reduce to? Pi. So we've got negative 1, 0. What does that reduce to? So that's gone. Minus, parentheses, the 11 times negative pi over 2. It's similar to that other problem that we did. Minus... what's going to happen with both of these again? They're going to zero out, right? One of them's going to be down here, and one of them's going to come back there, so I'm going to get 0 off of both of those. So I really have 1/2 times 11 pi over 2 plus 11 pi over 2. So 11 plus 11 is 22 pi over 2 times 1/2 is... 11 pi over 2. All right, number 8's actually a really good problem too. It's not as long as this one. We got to find length of a polar curve. Okay, so we're doing arc length again, which means we have to do the function plus squared plus the derivative squared, right? And I'm going to integrate from where to where? 0 to 2 pi, and I want the square root of the function squared, which would be e to the 2 theta, plus the derivative is what? E to the theta, so square the derivative, d theta. Okay, and when we add these together, how many of them do we have? 2, so we've got 2e, I'm going to write it a little bit different, theta squared. D theta. Isn't square root of 2 a constant? I could pull that out front. So now I've got the square root of e to the theta squared is going to be what? E to the theta. When we integrate e to the theta, we get It doesn't get any easier than that, right? From 0 to 2 theta. Sorry. My pi turned into a theta. How did that happen? All right. So now we're going to plug in. So we end up with square root of 2 e to the 2 pi minus square root of 2 e to the 0, which is, that's just going to go away, isn't it? Isn't that one of our choices? Well, what would I have to do now to get one of our choices? Pull out the square root of 2. See, that was a good one. Okay. What do we need to get through on the other one? You have about 14 minutes. We're not going to probably get to them all. Number 12. So we're starting from the back is what you're telling me. Okay. All right. These ones here, I kind of defaulted to the calculator a lot. Okay. So, when we look at so go ahead, get that in your calculator really quick. Okay. So you can at least see what the picture looks like. Okay. Doc B. All right, 4 sine theta. Oh, I'm not in the right thing, am I? Polar. 4 sine theta. All right, and then the other one was 2. All right, so there's our picture. Nope. That's you guys. Okay, we ready? So it wants us to find the area of the common interior. So we're basically looking for the area of this whole thing, but couldn't I just do half of it and multiply by 2? Okay. So if I do half of it, so and I know I'm going to multiply everything by 2 in the end here. Okay. What would we guess, educated guess, that radian measure is? It's a pi over 6. Okay. And then it goes all the way to this radian measure, which we don't have to guess, is what? Pi over 2. And again, on the test, I'll put the decimal points up. You can go ahead and trace over the top and get close and estimate that that's pi over 6. Okay? All right, so I know it's 1/2 for my formula, 0. Oh, this one's weird. I gotta erase my scribbles, okay? So, it's weird where this stuff is coming at us from, okay? So I have to look at this part right here is the blue curve, and that part up there is the red curve, right? So I have to really go from 0 to pi over 6 for the blue curve, and then I do from pi over 6 to pi over 2 for the red curve. So I go from 0 to pi over 6 of my blue curve. Which one was the blue curve? The 4 sine theta. And then we're going to square it. Okay? I'm going to put the 1/2 on the outside. And then plus, should be a d theta. Plus, I'm going to go from pi over 6 to pi over 2 for the other curve squared. 2 squared. And then you hit the buttons on the calculator and let it see. That's what we did last year. I looked it up. And you get this. Hopefully. Okay.
So you do the blue one first because you're trying to get the little like curved triangle out of there?
Yeah.
Okay. But is it
Well, it's really, no, it's not. You're getting, the blue one gets you this chunk here, and the red one gets you this chunk here. It's kind of strange.
Because that little triangle that you pointed out
Correct. It wouldn't be inside the blue circle. It's weird how it. Let me try drawing the picture again. Because what the blue one gets you is this little piece, that sliver right there. Does that make sense? And then the next one's going to start from pi over 6 to here, so it would get you that sliver. Does that make sense, Andy?
Yeah.
Okay. It's hard to see with the polar. All right, what else do you want to do? Which one? Number 1? Is that right, Manny?
Yeah.
Okay, Manny wants to do number 1. All right. Oh, not that number 1. You want to do number 1 back here.
Oh yeah.
All right. Magnitude and direction angle. So, magnitude means that we are going to square each one of those, right? So we have negative square root of 2 squared plus square root of 2 squared. So let's see, we end up with 2 plus 2, which is 4, which is 2. So there's your magnitude. Here's how I would come up with the direction angle. Those are very unit circle-esque, aren't they? All right, so really the only thing we're missing is that part. So negative square root of 2 would go that way, right? Positive square root of 2 would be up here. What radian measure would that be? 3 pi over 4. All right, what else? 2. Okay, so component form, remember we basically do this, a trig times that. Okay, so what trig always goes in the x spot? Cosine. And what trig always goes in the y spot? Sine. So 6 cosine 270 sine 6 sine 270. Plug it into your calculator, get the decimal.
And it has to be in degrees, right?
I think so. I don't know. I did it in radians. Maybe it'll be multiple choice, and then you'll be able to figure it out, right? I'd have to look again at the. I didn't go back in and look at the work on the page on the book work to see which one they did it in. If you screwed it up, I'd probably give it to you tomorrow. Okay. All right. What else do you guys want to talk about? I put 5.906 and negative 1.056, but I did it in radians. I don't know if it may have had to have been in degrees. I'll check it when you guys leave, okay? Number which one? 3. I'm not going to stop and check it right now. All right, so number 3, we need the component form. Basically, this says multiply by negative 2, multiply by 4, and then add the 2 vectors together. So when I multiply this one by 2, what do we get for our new vector? Good. And we multiply this one by 4, what do we get for our new vector? Negative 12 and 20. Add them up. Oh, thank you. My sign should have changed, right? Okay, so now add the 2 vectors together. What do we get? Negative 20 and 22. The other one is the magnitude of that. So basically take this thing, throw it under your square roots, right? Figure out that number. Okay? All right, what else do we need to talk about? Which one? 5. All right, a particle travels with position vector. Find the velocity and the acceleration vector. Do you really want me to do that one? Derivative, derivative. Okay, make sure you don't forget the chain rule. 7. All right, 7's probably a better one to spend our time on. Okay, so for number 7, what values of t does the curve given by the parametric equations have a vertical tangent? All right, so let's think about this. I know I get tangents from the derivative. And really our derivative is dy dt over dx dt. If I have a vertical tangent, that means my tangent to whatever the curve is looks like that. What's the slope of that curve? It's not 0. Undefined. How do I get an undefined slope?
We'll put 0 on the
Put a 0 where? Denominator. So really what I need to do is I need to take the derivative, the dx dt, and set it equal to 0. So let's find dx dt. What's dx dt? I heard 3t squared minus what? 2t. Set it equal to 0. So let's see, what can I take out? T, so 3t minus 2. So what two places is there a possible horizontal tangent? 0 and 2/3. 8. Okay. Let's find that one. That one's on my phone. 7. Oh, maybe not. Did we not do 8 last night? I thought we did 8 last night. I didn't write it down. Alright. Particle moves in an xy plane, so we're given this position. What's the speed of the particle when t equals 3? So who was here last night? What did we write down to begin with?
B equals square root of -5 sine 5t squared plus 3 squared.
What equals the square root?
-5.
Let me see. Maddie's just going to give me hers. Alright, so... Oh, we have to just do the magnitude. Okay, it's basically the magnitude. That's what Maddie wrote down. She wrote basically magnitude. Alright, so we need to take the derivative of that and square it, right? So what's the derivative of cosine 5t? -5 sine 5t squared. What's the derivative of this thing here? 3t squared, right? It gave us a number, didn't it? Yeah, what are we going to do with the number? Plug it in, use your calculator. Okay, so put your number into that thing. So -5 sine of what? 15 squared plus 3 times, so it would be 27, wouldn't it? Squared, and whatever that turns out to be. I don't know. I don't think we did it all the way through. We stopped there. Number 9. Okay, remember 9, we're getting rid of D. We're only going to do A, B, and C. So magnitude of the velocity, magnitude's going to be there, isn't it? We've done it like 5 or 6 times at least. So magnitude, they give me position. How do I get the velocity? Derivative, but the magnitude of the velocity is basically the two derivatives squared, right? So what's the derivative of this first thing? 2t, and the derivative of the second thing is? 2t squared. How do I get the at t equals 2 part? Plug in a 2. So let's see. 16 plus 69 is what I got. So the 4 squared and what? 8 squared? Oh, sorry, not 69, 64. Can't read my own handwriting. So I got square root of 80, which is I don't know what in decimal. All we have to do on B is set up an integral. That shouldn't be too hard. Total distance is the integral of the magnitude. So we go from 0 to 4, and we throw the magnitude in there. Plus 2t squared dt. Done. And then this one was tricky. If you wait just a minute, I'll put it up there. Get it done quick. You have to do dy dt over dx dt. Okay? So that would be, we know dy dt was 2t squared, dx dt was 2t, reduces to t. The catch is it has to be as x, so I'm going to solve that thing there for t. So you got x minus 2 equals t squared, so t equals the square root of x minus 2. That's what it equals. It should be, yes, it should be plus 2. Sorry, I did the wrong operation. Okay. I think that was almost all of it, wasn't it? With the exception of maybe 10 and 11. Those are the only two we didn't really get to. So you should be pretty good for tomorrow. And I will look up the radian or versus degrees here in just a minute and text you.
Rebecca Mendez.